Hello and welcome to Tableau Conference. Are you excited about Tableau's new features? Yeah. Woo! Yes, we are excited about them. We are excited about enabling you to make those important visualizations, to draw those insights from your data. We want our Tableau interactions to be fast and intuitive. It's important that you are in that frame of thought to explore your data and not worry about performance or query response times. This presentation is mainly to provide you with the tools and resources to investigate any performance issues that you see. As customers, you understand your data way better than the Tableau support team or the dev team. So please do make use of this opportunity to get a feel for what Tableau generates to improve your query performance. Let me introduce myself. I'm Priyatham Pamu, and here is my colleague Luis Enciso. We are part of the Tableau query team. The charter for the team is to improve query performance across all Tableau products and also to add new constructs to query data. We are going to start off with an introduction to query ecosystem, and then Luis is going to introduce you to performance, and then he's going to walk you through a few scenarios and cover the different queries that we run. Towards the end, I'll be covering some of the query optimizations that we have in the product today, and also the logging that is enabled right now. And we'll have Q&A towards the end. The motto for the query team is to generate fewer and simpler queries. Fewer queries, so that means fewer round trips to your backend database, and simpler queries, so you could have more cache hits. Tableau supports about close to 60 different data sources. Most of them are relational, a few of them are MDX-based data sources. It's the same query processing that happens for all the relational data sources. And if you are interacting with your live data source, or if you have extracted the data into Tableau, it's the same query processing that happens, even if you publish it to a Tableau server. Let's say you have a federated scenario, like you want to pull in data from Oracle database versus your data from SQL Server. We call them as federated connections. Even in this case, we use the same query processing. Another important part of query ecosystem is Hyper. By now, every one of you are well familiar with Hyper. Hyper is a very fast data engine that comes inbuilt in Tableau, whether it's a Tableau data desktop or the Tableau server. When is it used? Whenever you have extracted the data, or if you are using a file-based data sources, like your Excel file, we move all the data to Hyper, and we run queries against that. And even in case of federation, where you are trying to pull in data from different databases, we use Hyper as a federation engine, as a place to join the data and union the data. Now, Luis is going to introduce you to performance.
So in this next section, we will cover the performance basics. As Pamu mentioned, we both work in the query team, and over the last few years, we have seen some workbooks that are really awesome and really performant, but we have also seen some workbooks that really struggle with performance. So we hope to give you some tips in this session to help you achieve better performance in your workbooks. We'll first go through a simple example where we will find and fix a performance issue. This should be a good warm-up for the rest of the session. One thing that you have to have in mind for performance is that you always need to measure. Performance and measurement go always hand in hand. the measurements that you take will be your guide towards achieving your performance goals. For doing measurements, you need a measurement tool. And this should be ideally easy to use, be precise, keep you in the flow of analysis, and don't affect the performance. We will start with the most basic of them, the mark counter that is in the bottom left corner of Tableau desktop. In this corner, you can see how many marks, columns, and rows are being displayed in the visualization. And to talk about this example, I will go over a short demo with a visualization that you can find in Tableau Public. And for that, I will do a short demo. In this workbook, you can visualize the different fasting times across different countries in the world for Ramadan. The fasting period is defined to be from dawn until sunset. So depending on what region you are on, the fasting period might be longer. The chart above shows a map of the world with the different countries, and the chart below shows multiple semicircles, each of them indicating the fasting periods for each country. And it's arranged in a clock-like layout. The cool thing about this dashboard is that you can explore it. So whenever you hover over a mark over here, you can see the corresponding circle. And you can see that the countries on the north have longer fasting periods. And whenever I hover over a new country, the corresponding circle highlights kind of instantaneously. However, if we take a look at the same action but in the opposite direction, you will notice something different. For example, if I highlight Iceland, you might have noticed that there's a delay of about 2 or 3 seconds before the mark in the map is displayed. I will do it again so that you can see it, this time with Algeria in Africa. And again, there's a delay of about 2 to 3 seconds in there. So let's take a look at what's happening. I will go on this worksheet to open the map. And let's take a look at that corner that I talked about earlier. You will notice that right now we're displaying more than 20,000 marks. And that should be an immediate red flag. There's not that many countries in the world. If you take a closer look, I will do it with the marks that are over Australia. You will notice another thing. We're selecting over 323 items. And this basically means that there's more than 300 Australias overlap on top of each other, which is a waste of resources. That's why this dashboard is slow. The problem with this visualization is that it doesn't have enough aggregation, and it is showing the row level data by default. But since all these marks are being overlapped, it's not that easy to notice. So the way to fix this is to pick some of the fields that we can know that are repeated over and over again. In this case, the dawn and sunset fields are repeated. And we don't really care which one we pick, so we can pick an arbitrary value out of that. So you can do that with selecting either minimum or maximum, which I will do now. Again, with sunset. And after I do that, you will notice that the number of marks is now 48, which is way more reasonable. If I go back to the dashboard, you will notice that the interaction is way more smooth. There's not that annoying delay anymore. And the important thing for this example is to show you the performance workflow. You will have to find a number that you will measure and track, and then do several iterations to try to fix it. And it doesn't matter what measure you pick, it's normally the same thing. When do we see performance issues? The most common parameter is the data size. So the more rows you have in your data source, this will have a direct impact. But it's not only how big your data source is, it's also how much data is your dashboard producing. So it's the data in and data out. Also, the number of columns is just as important as the number of rows. We have seen some data sources that have hundreds of columns, and this has impact. Another dimension that is important is the complexity. If you make dashboards that have a lot of worksheets or that have a lot of quick filters, you will increase the complexity. And also, if you have calculations that are really long or that call other calculations, you will increase complexity, and with that, you will affect performance. So if we were to graph when do we see performance issues, we will see a graph like this. Whenever your data size or your complexity is big enough, you will start seeing this ring of weighting of boredom, which is something that users normally don't like at all. In this next section, we will talk about what happens behind the scenes and the different queries that we send to the databases and how you can take a look at them. We will start with very simple scenarios, and we will add complexity little by little. And we will start with one of the classic examples, which is the classic sum of cells examples that only has one measure and one dimension. And for that, I will do another short demo. Just give me a quick second. Switch. OK. I will be using the built-in Superstore dataset that is already in Tableau for this. I will open it. And before continuing, I want to introduce another tool that you can use for performance. It is called Tableau Log Viewer. And as its name implies, it lets you see and understand the logs of Tableau. The first thing that you need to do to use it is find the log of Tableau. And with this, you will see a bunch of events. Each of them is identified by the time when they happened and a key for the event type. It is very common to use Tableau Log Viewer side by side with Tableau, so it's something that I will do right now. Just putting it side by side. And before I continue with the rest of the demo, I need to refresh the data to make sure that I don't hit the cache or anything. One of the most important features of Tableau Log Viewer is that it lets you see these events as they happen in real time. And you can enable that with this button called Live Mode. And with that, I will start creating the visualization that we wanted. So I will drag the category field into rows. And you'll see that some events appear on the left. And right now, we're interested in the query events. And the best way to find these events is by using another feature of Tableau Log Viewer. You can access it with, here in the menu, highlight. And the name for the most common query event is called end query. So I will create an event for that, a filter for that. And after I do that, let's toggle this fast, you'll see that the query events will be highlighted in yellow. So there's one over there, and there's other three over here. And you will see that each of them is saying how long did it take to run in this elapsed column. Many times you want to get rid of all the other noise, of all the other events that you don't care about. So for that, you can toggle this button called Highlight Only Mode. And that way, you will only keep the events that you're interested on. And finally, another useful button is this one for clearing all the events, so you can start fresh. And we'll do that right now. And with that, now that we have a full setup, I will finish the visualization. I will drag the cells field into columns. And you notice that an event appears right here. This is the query that we sent for this specific visualization. You can double-click this event, and this will show you more details about this query. Among those is the SQL query that we sent to the data source. We will be talking a little bit more about this dialog later. I need to switch back here. Tableau Log Viewer is a tool that lets you view and monitor the logs for Tableau Server and Tableau Desktop, and it is an open source project. You can find it and download it in GitHub. As you could see, you can use the live capture mode to see the events as they happen in real time, and you can create multiple highlight filters, each of them with different colors. Some useful events that we will use in this session include the begin query event, end query, the QP batch summary, and abstract query. And just a reminder, we are recording this session, so you don't need to make note of everything of this. So that was the most simple example. Let's add a little bit more of complexity. If we add a filter, such as the one in the image, we will end up with an event that looks like this. There's many details. Let's see all of them. You will get stuff like how many columns and rows this query return. You will get the elapsed time. How long did this take to run? In this case, it was 7 milliseconds. This is one of the most common things to measure. You will see what connection we were using. In this case, it was a hyper connection. You will see the query category, and this is the component or the purpose of this query. And if we break down the SQL query that we sent, you will see that the dimension category appears over here, that the measure for sum of cells appears in the second line, and that all the elements for the filter appear in the where clause. Also, you might notice that at the end it says group by one. This is a common misunderstanding. Some people think, on the first time that they see that, they think that it says group by the number 1. But what this actually means is group by the first thing in the select list. In this case, it means group by category, because that's the first thing that is mentioned in the query. As we mentioned before, Tableau can connect to more than 60 different data sources, so the SQL statements that we send to each of them can be slightly different depending on what you're connecting to. So now that we saw what happens with small filters, where you can see them straight in the query, you will get a different behavior if you have a very large filter. For that, we would use a temporary table. And it will be in play whenever you have filters such as this. In this case, we are selecting more than 500 customers. So instead of putting all of those elements in the query, we create a temporary table. And if you look at the events that happen behind the scenes, you will see that there's a query that we will send with the temp table category. And you can see that really long name for the filter, for the temporary table. Then you will see another event for populating this temporary table. So this is inserting all those rows in there. And finally, you will get the data query, which will be using that temporary table. Something important to have in mind is that when you're improving performance, you don't only want to target the last query, because it could be that the performance issue is actually happening when you are creating or populating that temporary table. Another kind of filters are quick filters. And the thing with them is that we need to send an extra query to get the different values that we will display in the UI. And quick filters have an option called show only relevant values, which if you have multiple filters, if you think that they will affect each other, it's a very useful option. However, they come with a cost because they might involve queries that are more complex and that have joins in them. So avoid this if possible. Another side effect of using relevant values is that it triggers another query that we call acceleration views. This basically pre-computes all the different states for all of these filters. And this happens asynchronously, but still is another cost. If we were to take a look at the different queries that we sent for a dashboard or a visualization like this, we will send one query for the main visualization. No surprises in there. But we will also send 3 queries for each of the quick filters. And in addition, since some of these quick filters use the show only relevant values, you will see an additional acceleration view query. So even if this visualization is simple, behind the scenes is sending at least 5 queries. Let's move to another scenario, which is what happens when you have a visualization with multiple connection data sources. We call this data integration or data federation. And this is to combine data from multiple data sources. As Pamo mentioned, we use Hyper as our federation engine. And it will come in play whenever you have a data source like this, where you bring tables from different places. And you can distinguish that because the tables are using different colors. Behind the scenes, Tableau is thinking of queries more or less like this. Let's imagine a scenario where you want to combine cells from your Microsoft SQL Server with your customer data in Oracle. And let's suppose that you have a filter on the customer data in your visualization. The issue with with the state of the query right now is that the data is in different places. So it cannot actually be executed in this way. So what we do is that we first take the data from Microsoft SQL Server and move it to a temporary table in Hyper. Then we do something very similar with the data in Oracle. But in this case, we are a little bit more clever, and Tableau can identify that there's a filter on customer. So it will first apply the filter, and then it will move the data to another temporary table. We apply the filter first, because that way we will move less data across databases. And finally, now that we have all the data in Hyper, Hyper will finish the job and apply the join and the rest of the query over there. If we were to take a look at all the different queries involved in here, you will have one query in the context of SQL Server. You will have another query in the context of Oracle. And you will have multiple queries in the context of Hyper. There's 2 queries to create these temporary tables and one final query to compute the final results. The next scenario is all about calculations. And for this, we are going to take a look at another Tableau public visualization, which is analyzing the tweets from the Prime Minister of India. And we will be focusing on the scenario for doing the calculations to find hashtags in tweets. And before I show you the original calculation and how to improve it, let me show you the original query. You will see something like this. So needless to say, this is really long and complicated. And actually, the complete query didn't even fit in the So what we want to do in this case is do string manipulation calculations. And for your reference, I put in the upper right part a tweet from the data. And we want to get the hashtags. So let's remember that we want to get hashtag yogaday from here. The original calculation looks like this. And the approach goes like this. It first checks if there's a pound symbol in the tweet. Then it finds the position of the pound symbol. And then uses the mid function to get the text section after the pound symbol. So it basically finds the pound symbol and keeps everything after it. So we have made this protocol so far. We would get hashtag yogaday as success. So we're still not done. We want to get just the hashtag. So for this, the original approach is using yet another calculation. And it will look something like this. So the calculation from the previous calculation is highlighted here in red and is used here 5 times. And this calculation follows a very similar approach than the first one. It first checks if the value has a space, finds the position of that space, and then uses the left function to get the text section before the space. So basically, it finds the space and keeps everything on the left. And with that, this calculation will accomplish just getting the hashtag. And but there are several problems with this calculation. You might have noticed that the calculation is not complete and doesn't handle all the test cases. So for example, what happens if instead of a space, there was a dot or a comma after the hashtag? If you wanted to handle that, you will have to create an even more complicated calculation on top of this. The other obvious problem is that this is, if you think that these calculations are very complex, Tableau thinks the same, and actually it will not perform that well. So now that we saw the original approach, what would be the alternative? For string manipulation, it would be using regular expressions or regex calculations. And the calculation in this case would look something like this. For all of you that might not have used regular expressions before, I will break it down little by little. You basically need to describe what you want to find. And a hashtag is basically a pound symbol followed by many alphanumeric characters. So what we need to do is find the pound symbol and then many alphanumeric characters. Alphanumeric characters are represented by /W, and the plus means ones or more. And finally, we need to capture this expression, and we do that with parentheses. And that's all. That's basically this single line calculation will accomplish the same or more than the previous pair of calculations. You don't need to have any ifs, you don't need nested calculations, and you don't need to use multiple functions such as find, left, or mid. So the main tip for doing a string manipulation is to invest some time to learn regular expressions. And don't get intimidated by them. Regular expressions are not a concept exclusive to Tableau. Many applications use them. And because of that, you can find a lot of resources online. One example is that there's many websites that help you write and test regular expressions. One of them is regexer.com. In there, you can, one of the tips is that you can copy a section of your data over there and write your regular expression and test it in this site that will help you interactively build this regular expression. And after you're done, you can just copy-paste the regular expression back to Tableau, and it should just work. We will take questions at the end of the session. Another tip with complex calculations is that if you are already using an extract, you can try optimizing it. And by that, I mean there's an option in the extract menu that says compute calculations now. This option will pre-compute all these calculations and store them back in the extract. So then the queries will not need to calculate them again and again. With that, I will give control back to Pamu for the end of the presentation.
Thank you, Luis. Here we are going to take a look at a level of detail calculation. The LOD stands for level of detail calculation. I'm going to take an example of cohort analysis. Cohort analysis, basically, you want to understand the behavior of groups of things, like groups of users, groups of customers. Here, the example I picked is you want to see how the revenue generated by your customers, but you want to group them by the customer acquisition year. So basically, I want to build a visualization like this. It's a very simple visualization where years on the rows axis and sales on your y-axis, but I want to color code them by their customer acquisition year. That is when the customer first started using your product. Here, I would drag the order year onto the rows and the sales onto the y-axis, but the only thing is the year of customer acquisition. If we could define a calculation to capture that, we can do this visualization. And when you think about year of customer acquisition, it's basically for every customer, you want to know when is the first time they have purchased. So you want to get the minimum order date for that. So Tableau allows that using level of detail calculations. You could fix on the customer ID and you say, give me the minimum order date. So that's how you compute the customer acquisition date. From there, you could get customer acquisition year. Whenever you do that, under the covers, we generate a subquery just to compute that. For every customer, give me the minimum order date, and then we join it to the main table. So you would see a SQL like this. So it always results in a subquery. LOD calculations are very powerful. Like you could build complex analytics with that, but they come at a cost. So avoid using too many of them in a single view or using them in a nested scenario, because as you use multiple of them, the SQL will start getting complex. And another scenario where we generate queries is during extracts, like when you're creating them or you're maintaining them by doing full or incremental refreshes, or even when you do compute calculations. Like Lewis mentioned, if you want to optimize your calculations, you want to pre-compute them. So even then, it's the same query processing that's done. I'm going to go over a couple of scenarios. One is that in the Tableau desktop, whenever you're creating an extract, it runs the query against your live database and then inserts into the hyper extract. In the case of Tableau server, it's your Tableau backgrounder process. Based upon whatever schedule that you have set, it will query the database and again populate the hyper database. Now we are going to go over a few of the query optimizations that are there in the product right now. So far we have gone about, okay, what type of queries that we have generated. Now we are going to look at, okay, what kind of optimizations we do. The most basic one is query caching. It's always enabled by default because it always helps, except for scenarios where you are doing something based upon the current date or current time, which is like a relative date filter. We always cache those results. And whenever you refresh your data, that is, your data source has changed, then we expire all the cache entries and we start over again. And right now, the cache, we have both an in-memory cache as well as an external cache. The beauty of having an external cache is that even if you restart your desktop or Tableau server, the cache can have hits. Also, if you have subscriptions, then the external cache helps you because you could warm up your caches and then send out the subscriptions. So when your end users interact with it, they have faster response times. And there's also 2 levels of query caching. One is a higher level, like once we call it the abstract query cache. We are looking at a very higher level. And another is the lower level where we try to process it and then convert it to SQL. And that's the lower level of query cache. So here I've taken an example. You have 4 queries that we want to process. First, I check against the higher level query cache. First, the in-memory, and then the external cache. And in this case, I was able to process 2 of them. And for the other 2 queries, I'm going to compile them into SQL and again look up this native query cache. Again, in-memory and then the external. And if we don't find a match, then I'm going to hit the database. So the goal is always to avoid running against the remote database and always try to make use of your cache results. And once you run a query, we want to cache those results, and we do not cache them always. This chart shows you when we do. On the x-axis, I have the time taken to run a query, and on the y-axis, you have the result set size. Whenever your queries are slow and the result set sizes are small, we want to cache them. But for larger result set sizes, we don't want to cache them as they take up a lot of cache space. Or for fast queries, you're better off running those queries against your remote database. Here I've taken an example where we do something like partial matching. Here I have started out with a scenario where there's no entries in my query cache, and I have a viz where I want to compute the sales for all cities in the United States. So since there are no entries in the cache, I have to process it. So I'm going to generate a SQL query for it. And I'm going to run that against the remote database and then cache those results in the query cache. The next visualization is give me sales for all United States. This is something that I could aggregate upon the existing data in the cache. So in this case, I could just use the cache results and process them in Tableau. So there's no SQL query generated here. The third scenario, I'm querying for give me sales for San Jose city, a particular city. Here you can use filtering to avoid running your queries. The fourth one is give me the sales for all regions. So in this case, you are asking data for regions, which is not already there in your cache. So you have to run another query. And once that query is processed, you are going to cache those results in the query cache. So we basically use this partial matching to avoid running queries in scenarios where you could make use of existing results. And whenever you see a cache hit, there's a cache hit abstract. It means that it has hit one of the caches. If it says cache hit none, it means it has to run the database query. Usually queries which we have to run against the remote database are the slow running ones. We also do something called query batching. Like let's say you have a dashboard. You have a lot of quick filters and you have a lot of sheets. Instead of running one query at a time, we go through the whole dashboard and compile a list of queries that you need to run ahead and do a dependency analysis on that, like what is the actual minimal set that I have to run queries for? And we try to run those queries in parallel. And then the queries that could be inferred from them, we run them against the cache. And there's also something called query fusion. Let's say I'm interested in sales for all cities. And also, there's another viz where I want interested in getting cost for all cities. I could just club them up. So you fuse those queries if they're at the same level of detail. Here I'm going to take an example where there's a dashboard. First, I look at the dashboard and figure out what all the queries that I need to run. Here I have 6 of them. Instead of running all at once, I'm going to do dependency analysis on that and figure out that only Q5 and Q6 are the queries that I really need to run against the remote database. As for the other ones, the dependent queries, I'm going to run it against the cache. So first you run the Q5, Q6, those results will get into the cache, and then you run those 4 queries against the cache. So the goal is always to avoid running duplicate queries or queries that you could infer from others. You leverage your query cache and also try to use your local processing on top of your query cache results. This is a scenario where we have 7 queries. On processing them, we figure that there are only 3 queries that you really need to run. So I'm not going to go over all of them, but take one example where the ones that are highlighted are the 3 queries that could be just answered using one query here. And there's something called a query batching event. And when you're looking at the logs, this is the main event where, for a dashboard, it will capture all the queries that it's run. And it gives you information on how much time it took to run that, the number of queries it had to process. And then it goes about each query. It tells you what is the source of the query, like what worksheet it's coming from. What is the category, like whether it's a quick filter query or it's a data query or it's a temp table query. So it tells you the type of query it is. And if it has had to run it against the remote database, it will also show you the SQL query that you are populating. And also, like, this query ID is assigned. And we repeat the same thing for every query, every job in this batch. This is very helpful if you want to take a look at one event that tells you how your dashboard or worksheet is doing. There are some limitations. Tableau, there are some queries that you could, just looking at the viz, could know ahead, but there are some that it has to post-process. So based upon your results, it has to process them. So in those cases, you cannot do query batching. Or if you want to do metadata queries, like you want to know what are the data types, or what are the columns that you have in your table, or what are the capabilities of your database. So for these, we run some metadata queries. Then we have query categories. This is an interesting thing to look at, just to know, just by looking at this, you would know what type of queries it is. Especially when you are seeing performance issues, it's good to see what's taking up most of your time. The data queries are the most prominent ones because you are aggregating on your measures, and they involve a lot of joins. And then we have metadata queries, which are usually when you're setting up your first time when it's making a connection to your database. It runs a lot of them to figure out what columns you have, what are the data types, and so on. Domain queries, like let's say you're populating a filter, it has to run domain queries for that. If you are generating a quick filter, relative query, like give me the sales in the last 10 days. So it needs to compute what's the server time. So there are several other such query categories that it needs to run to really get you the final visualization. I have this slide where we have detailed exactly the descriptions for each of them. So if you're interested, you could take a look at it later on. As for query logging, for Tableau Desktop, right now, it does querying against your remote database, as well as if you are using Hyper, it runs queries against Hyper. So the logs are located in these locations, and they are you could use the same Tableau Log Viewer to analyze these logs. The two important processes that you want to watch out for, one is the tableau.exe, and the other is hyperd.exe. So most of the query processing happens in Tableau, but if you are using extract or for some reason Hyper, then you would be interested in the hyperd logs. In the case of Tableau Server, there are a lot of processes in Tableau Server, but here we are interested in two important ones. One is the visual server log, and the other is the data server. So let's say you have a visualization, you are looking at it through a browser. First, the visual server processes it, and if it's a published data source, then it queries the data server. So you may be interested in data server logs in that case. And if it is a remote database or if it's hyper, it queries against those databases. So these are the processes you'll be interested in, like vSQL server, data server, and if you are running extracts, like you have created extract, you want to do incremental refresh or full refresh, you want to take a look at the backgrounder for the logs on those. And with that, if we come to the end, you may be interested in these related sessions, show me the queries, and designing efficient workbooks. And also, if you have any ideas on how we could improve queries for your data sources, please feel free to reach out to the Tableau dev team. Many times the feedback that we get from the customers is really helpful in improving our queries. Thank you.
I got a reason, so man, put that record on again. I don't wanna hear sad songs anymore. I only wanna hear love songs. I found my heart up in this place tonight. Don't wanna sing mad songs anymore. Only wanna sing your song, 'cause your song.
So if you have any questions, please let us know. We will be taking questions now.
Doesn't have an insert
yes.
file when you download the log viewer?
There is a zip file.
Use a zip file.
Yeah.
Zip it, but you have to
You have to unzip the zip file, and then you have to run the exe in there.
So just repeating the question for the
There should be a
recording,
latest releases and
Hyper is
everything.
already built into Tableau, so you don't need to do anything to set it up or anything.
So I have 10.2, so it's already built
No, it's in 10.5, I believe, when it. So yeah, if you don't have 10.5 or newer, Hyper is not there.
Page. If you scroll down, there will be something called latest releases, and if you click, yeah.
Yes. Yeah, you should still see it. Go ahead.
Can we
Yeah, you
delete them to create a new query set for our next refresh to observe how the query is working?
Yeah, so the question this time is if we delete the logs or stuff like that. So basically for Tableau Desktop, every time you open a new instance
That's
of
what-
Tableau, we delete the old logs and we create a new one. If you don't close Tableau Desktop, it will just be using the same log file. For Tableau Server, since Tableau Server is always on, I believe we create a log for each day. So after a day, it will put like a long name with the date, and each day it will be a different log.
Just like you kept Hyper on the left side to see how the queries are being affected, I can look into the logs also and see how Tableau is, how the queries are affected.
Right, so if you have access, for doing the Tableau Server one, you will need to have access to the Tableau Server. So if you're an administrator of Tableau Server, that will not be a problem. So yeah, just refer to that location of the Tableau Server logs. You're welcome. Hello.
In one of the slides, you showed that 7 queries effectively reduced to 3 because they were
Correct.
Data, basically the same data being queried in a different way. My question is that how do you, if the Tableau generates those 7 queries, what can you do? What is actionable here? See, one thing is knowledge. There was
Right.
a lot of knowledge about what is happening and how things are happening. But how can we actually influence it? How can we change the course of the game?
Right. So a lot of it comes to workbook design. The related talk about I think let me pull it out right here. Designing efficient workbooks will be talking a lot of. It will be giving a lot of tips about doing that because now that you can see what queries are being executed, you might have a more insight, and maybe that will give you that will make you realize that, oh, I have too many quick filters, or this particular one is the one that is very expensive. So maybe if it's acceptable, then maybe that quick filter can go away or be replaced with some field that is not that complicated. So yeah.
Okay, thank you. If you don't mind keeping out.
Yeah, sure.
I'm surprised by your recommendation to use regular expressions.
Right.
It's great. Does that only apply to extracts or only when it's not in a filter?
No, so the question for when to use regular expressions. So let me see if this answers your questions. Regular expressions are not available in Tableau for every connection. So for extracts, it is enabled. So extract connections are enabled. I don't remember all the different data sources that are available.
Okay, so it'll be dependent on that, right? Like certain SQL databases don't support it or don't support the complete set. So
Correct.
calculated at the super level then?
Well, for some databases don't even support regular expressions at all. So even if you want to create a Tableau calculation, it will not give you the function name. It will not appear.
Okay.
So if the regex, for example, the one that we were using here, regex_extract appears, then it is available in your data source. Yeah, you're welcome.
Question for you, if you have Tableau server, how do you determine when to refresh the page?
That's a good question. Question is, if you're running Tableau server, when do we know how to refresh the cache?
Actually, this relates to my question. When the user refreshes the cache, or when Tableau is doing it in some sense automatically?
Right.
Users don't like the idea of having to hit the refresh. You just want to go to the dashboard
Right.
and know if they have the right data.
Right.
And a lot of our connections are live. Some of them are extracts. So we're assuming if it was an extract that you would clear the cache, but I think in some cases we're not seeing that. Don't quote me on that. But I'm just wondering, what are the rules? How do you determine?
So in Tableau server, if you click the refresh button, it will clear the cache for that particular workbook, I believe.
Is there any way to do that without them having to hit the refresh?
I have come across this problem. I think there is a setting. You can configure it.
Yeah, I actually don't know.
Can you turn it off completely, or can you?
You can turn it off completely on the whole server, or you can invoke a force refresh from the URL action, or from the URL by typing
Refresh equals
colon
Y.
refresh equal to Y or something.
Yeah.
But you cannot set it up on a workbook level. Let's say this workbook should
Right.
never use the cache if cache is enabled.
Right. So yeah, that might be something that we can take a look on.
We're able to do, so in cases where we actually call it using a URL, that works, but a lot of times they just navigate to the server itself. So that doesn't.
Right. Yeah, one of the disadvantages of using the refresh equals Y in the URL is that it will avoid all caching. And if your dashboard is slow enough, it will always do everything. So it's a lot of stress on whatever data source is hitting. So that's something, but that's the question on the rules of when, because obviously we refresh the data even if you don't click the refresh button, but I don't remember the exact rules. I think it's after a certain time, but I honestly don't remember right now.
How do we find that out?
Maybe I can find out and then send you an email or something.
Sure.
Yeah. Yes, please, if you can find. If you can come, I guess you can just write it down here. If you can write it down in this notepad.
We'll be happy to do that. Thank you
Yeah,
so much.
no problem. Yeah.
Yeah, in a similar kind of world, currently, the reports that I'm presenting, we'll have a data analyst extract from a much larger database and then put it into Excel, okay? And then I link to the Excel,
Okay.
okay? And I am thinking of trying to move to a world where we are querying the source database, which is very large.
I see. Okay.
So I don't know, I'm trying to get a grasp of what the costs are to doing that. So, I mean, if I do that and I open up a book, it's going to then query this larger database and put it in cache. And
Turn to see. So right now you're saying that the data is moving. Someone is moving the data
right now
into
the
an
data
Excel.
is fairly small.
Right.
because all of the hard work of querying
Was already
has
done.
been done offline.
Okay.
And then exported into Excel.
Mm-hmm.
So I'm wondering, like, what's going to happen if I am having Tableau
Mm-hmm.
query the larger database directly?
Right.
Okay,
I guess.
So then it can be a little bit more live, but I don't know, like, when is the, I guess it's then it's using this intelligence to create a cache,
Mm-hmm.
and you said it sounded like the cache remains even if the workbook is closed, even if.
In some occasions, if we can get the data will live on if it gets into the external query cache, but that doesn't always happen. So.
What are the basic principles in which that's happening?
External query cache. I believe we don't keep, the external query cache is not that big, so I don't remember what is the threshold. But if your data size is too big, we're not going to store it. Because basically, the external query cache, if you have a twibx, .twbx, it will be stored inside of there. And we try not to store too much, because that will make the file bigger.
Okay, so otherwise, every time someone opens it up, it's making a fresh query into that larger database.
Right. So yeah, for your case, I guess the only way to know is just to try and see if the performance is okay.
We may try simpler queries before we really filter it down.
And another possible solution in your case is use Tableau Prep. So Tableau Prep can do the automated work of connecting to this big data source that you have and creating the smaller ones that Tableau will do analysis on. So that would be another approach. Okay. Welcome. Yeah.
So the total calculation will be 40-ish. The nasty calculation and the LOD calculation, which costs super small on the desktop.
Okay.
And I don't know how to, because they're not going to do that in the database. So I don't know how to improve that on the desktop.
So you have some calculations that you think can be improved? Is that what you're saying?
Yeah, I have a lot. I have like 30 LOD,
Right.
a level of detail calculation, and some nested, or like the if statement.
Right.
I don't know how to improve that part.
Right. There's some, because this is a complex question. There's many things that you can do. Probably the designing efficient workbooks one will give you more detailed tips about it, about how to go about this. There's also some resources online. I can follow up with you after this Q&A. Yes, yeah, you can kind of. Yeah, actually, the Designing Efficient Workbooks white paper that talk is based on that white paper. Yeah, so it's not the same presentation. It's this was more about behind the scenes, what happens, and that's more like, hey, don't do this kind of dashboards or stuff like that, like because it will suck, kind of deal. Yeah. Show me the queries. I don't know. Let me see if. Show me the queries. I actually don't know exactly what it will be on. I think it will be. It's a little bit more on the research of the queries, and if you are interested in seeing how Tableau visualizes its own queries, that could be interesting. Although it is not related to performance. Show me the queries not related to performance.
So if you have a long calculation that references other calculations, is it better to put just to kind of all write it out into one big calculation rather than referencing others?
The question of
you were saying with the hashtags.
Right. So I mean, in this case, you will just instead of having several calculations, you will have a bigger one, a single but bigger one. I think it will have the same effect. So it wouldn't be an improvement.
I would disagree that it's better to split it up if it's like row level calculations and you're on an extract, because then you can optimize each sub element in like the compute calculations now.
Right.
already. So that will basically, let's say it's just something like, if something is called east, then call it e instead, like these kind of things, which are like just like data manipulations. If that's in its own field instead of in like its own calculated field, then that specific value can be basically materialized in the hyper extract, or it could be done on the
Right.
side, on the table side. Whereas if it's one long big long query, then maybe some of the elements in the long query cannot be materialized, and if not everything can be materialized, then nothing will be materialized. Whereas if it's split up, then maybe some of it can, and some of it cannot.
Right.
That's my experience on that one.
Right. One tip on the materialized calculations or compute calculations now. LOD calculations will not be stored in the extract, and this is because since they depend on the level of detail of the visualization, we cannot predict how they will be used. So basically, if you have an LOD calculation, it will not be materialized or optimized.